Kruskal Wallis H test is a non-parametric alternative of ANOVA when we are going to consider several independent samples. So if several independent samples are to be compared as far as their location parameter is concerned, then we make use of the Kruskal Wallis H test. So students, by taking a real life example, I'll be giving you the demonstration onto the use of Kruskal Wallis H test, which is also called one-way ANOVA by ranks. The problem I'm going to quote here is, it is the data about 4 groups of students that were taught using 4 different teaching methods. Their achievement test scores were recorded. So if you just see under the rows, we have the data for all the 4 groups, and along the y-axis, we have the achievement test scores of 4 groups of students. We have to test whether the distributions of test scores are same. Now, if we just look into it, students, यहाँ पे आपके पास जो total number of groups हैं, they are 4. And if we have to compare 4 groups with each other, then we will be making use of the Kruskal Wallis H test. Now, as far as the assumptions of the Kruskal Wallis H test are concerned, we are assuming that all the observations are considered to be independent across the group and within the groups. And if we talk about achievement test scores, they are quantitative. That means they are being measured onto the interval scale or the ratio scales. So we would be starting with the procedure of testing our hypothesis of interest using the Kruskal Wallis H test. So students, the first step we need to follow is the pair of hypothesis. So under H0, we have taken the statement that the distribution of scores, the achievement scores, they are identical, whereas under alternative hypothesis, we'll consider that distributions of scores are different from each other. Under level of significance, alpha is being considered as 0.05. The test statistic that we are going to follow, as we have 4 groups and those 4 groups are to be compared with each other, so we'll be making use of Kruskal Wallis H test. Students, यहाँ पे मैं आपको बताती चलूँ कि ये जो 4 ग्रुप्स है जिनके आपको scores given हैं, क्योंकि वो quantitative scores हैं, that means they are being measured on interval or ratio scale of measurement. So you might think of applying the analysis of variance or ANOVA to test the equality of several means under 4 groups. But obviously, this data that is being shared with you, it may not follow the assumption of normality. So we cannot apply the ANOVA for testing this kind of hypothesis. So we'll be making use of this non-parametric test, Kruskal Wallis test, to test this pair of hypotheses. So under H, we have 12 over n into n plus 1, summation Ri square over Ni minus 3 into n plus 1. So this is computationally relatively simple formulae that we are going to consider under Kruskal Wallis H test. Now students, the next thing we would have to follow is the calculation. So the first thing we need to do is that we would have to arrange all the observations collectively into a certain order from smallest to the largest, and then we have assigned the low rank of 1 to the most smallest observation, whereas if you just see, there were total number of 16 observations, so even the largest observation that also fall under group 4. So this is the way how we have assigned ranks to all the observations under the 4 groups. Now the next thing we need to do is, after assigning the ranks, students, as you can see, यहाँ पे आपको कोई भी tied observations नहीं नजर आ रही. That means there is no ties as far as the observations among various groups are concerned. So हमने अब क्या करना है further? हर group के ranks को sum up करना है. For example, if we are starting with group 1, so 3 plus 13 plus 6 plus 9, that gives us a sum of 31. So R1 is equal to 31. For the second group, we'll be summing over all 4 ranks, that is 7 plus 5 plus 12 plus 11. So it will give us a sum of 35, that we have assigned to R2. Similarly, for the last group, we'll be adding 16 to 15, then it to 10, and finally adding 14 to all these observations. We got the rank sum of 55. Once we have got all rank sums for the 4 groups, now we can plug them into the H formulae and we can calculate the H statistic. So, students, 12 over 12, which is a fixed value, 16, that was the total number of observations, यानी कि आपका capital N multiplied by N plus 1, that is 17, into summation RI square. So, students, पहला जो R आपके पास आया rank sum 31, उसका आपने square लिया, divided by N1. Total number of observations in group 1, they were 4. So, you divide it with 4 plus next rank sum 35, उसका आपने square लिया और divide किया with the total number of observation in the group 2, they were also 4. उसके बाद आपने इसमें add किया next rank sum, that was 15, उसका square लिया, इसको divide किया, again आपने total number of observation in group 3, they were 4, and finally we have summed up the rank sum for the 4th group, that was 55, उसका आपने square लिया, and again you divide it with the corresponding number of observations in group 4. So वो आपके पास 4 थी again, because we have the same number of observations under all 4 groups, minus किया आपने इसमें से एक factor 3 into n plus 1, where n stands for capital N. Capital N is the sum of all the observations, that is 16. So after simplifying this particular expression, we have got the value of H, that is 8.96. Now students, you need to compare this particular calculated value with the critical value. Now as you can observe that sample size, that means capital N, the total number of observations were much more greater than 5. So we'll be making use of the chi-square statistic to construct the critical region. So we'll be constructing that if H, which is our test statistic, it is greater than or equal to chi-square alpha k minus 1, where alpha is our level of significance, that is 0.05, and k is the total number of groups, which were 4, so 4 minus 1. So I've shared the chi-square table with you, students. A portion of it is being taken. So अब हमें 0.05 ढूंढना है, which is our probability, और 0.05 के against we'll have to locate a degrees of freedom of 3. So that value comes out to be 7.81. It is mentioned here. So students, अगर आपकी calculated value of Kruskal Wallis H test, if it will be at least 7.81, then we'll have to reject our null hypothesis. Now the last step is to compare the calculated value with the tabulated value. As you know that the value we have calculated under H was 8.96, and as you can see, it is much more greater than 7.81. That means we have insufficient evidence to accept H0. Therefore, it is concluded that there is a difference in the test scores for the 4 teaching methods using Kruskal Wallis H test.